So it's about elimination of a bromine in this type of system. So it kind of just plays with that.
Okay.
But anybody else find that question? Which one's faster? Or was it in the book, or was it? Oh, okay. There is an answer guide in the library.
Okay.
So on reserve in the library, I have the answer guide. I said that at the beginning, but people probably forget. Okay, good question. Good question. Other questions?
For SN1, how do you know if there's going to be like a translocation?
Rearrangement?
Yeah.
Well, experience helps. So if you're one carbon away and you can either move a hydrogen or a methyl, or in another case I showed you the phenyl, you can move a group and it gives you a more stable carbocation, it's likely. It's very likely. Just because just remember, we're talking about small amounts of energy. We're not talking about huge amounts of energy, and small amounts of energy results in pretty large percentages when you're talking about equilibriums. So if you're talking about an equilibrium between, say, a secondary and a tertiary carbocation, if that is a 5 kilocalorie difference, that's a huge difference between those two carbocations. So one thing if you can try to get this idea in your head, is that molecules are always moving. We write molecules like on a static. We write them static on the board, and we talk about them to be very static. But all that stuff is moving all the time. So, you can have rearrangements that are happening all the time, and if the two energy levels are real close to each other, you may not notice, you may not tell a difference. So, that's a good question. So, knowing which carbocations are better. So, like if I have this, and I'm reacting this, let's say I'm reacting this with ethanol. You may not, you may, and I say, what's the product? You may just say, that's the product. Okay? And I wouldn't mark you wrong for that, because I really haven't set that up to where you would know. But if you when you move to advanced organic chemistry, the product would be this, just because I know that in between here I'm going to form this carbocation, which is primary, and it wants to go to this carbocation, which is secondary and allylic. Okay. So down the road, with a little bit more experience, we'll ask you to do that. You're on. You're currently still, sorry, but you're still currently on bread and milk organic chemistry. So we'll introduce you to some larger food groups later.
So SN1 or SN2?
Yeah, it's a good question. It's a good question. If I were to, that's a great, okay, right there. It's a great question. Great question. Because I didn't tell you which product you got. So if you got this product, ooh, that marker doesn't work. If you got that product, if I say you get that, is it SN1 or SN2? Now I kind of set this up. Let's just say that's a solvent that usually runs things SN1. So let's forget about the solvent for a second. But let's say you got that product. Is that SN1 or SN2? SN2 for sure, because you never formed the carbocation. Because if you formed the carbocation, it would rearrange. And you would get that. So if you got that product, you have to say it's SN1. But this one, you're saying, if you run this one and you give me a primary carbocation, and you're going to show me a SN1 mechanism, I'm going to mark it off, okay? Because there are no primary carbocations. If you have the possibility of having, there just aren't primary carbocations, okay? They'll rearrange, always. They'll always rearrange. Okay? A good question. All right. Anything else? Another good question for the order of things. We'll do a little review, and then everybody got your cards? What number are you?
25.
You're in this stack. Cards? What number are you?
I think it was 30-something.
Odd or even? See if you're in here.
Wasn't this the odd one?
Did they get, some of them might have got shuffled a little bit. All right. All right. Everybody got a card? Everybody got their card? All right. Coming around. Are you odd or even?
Odd is right there.
You're already holding up an answer?
We've been working on it. And I think I know the answer by
I think it's
You can't use your book. Oh, okay. Gotcha. Everybody got a plicker?
the list to see whose name is what number.
Oh, it doesn't.
Lose that function when you update it.
I don't know if it's working right for me. Okay, here we go. Everybody got a card? This side of the room's ready. I don't know. This side of the room seems a little slow today. I don't know. Last time that side of the room was slow. Maybe it's where I stand. I'm project over here, then you're faster. What's that?
We have our cards on this side. But we got to find our cards and answer.
I just like, all I know that is if I introduce a little bit of competition between one side of the room and the other side of the room, doesn't matter what that competition is or anything, then...
She's smart.
Ooh. We should do that. You all have to agree on one answer. I'll do that one time. I'll tell you what we'll do is we'll review for the final exam that way. Okay?
Can you create a Jeopardy?
We'll do like a serious... Okay.
Yeah, we automatically win.
Here we go. Oh, I'm seeing lots of greens.
That's good because mine was one of the questions. Yes. So weird.
Are you coming up on the screen? Oh, okay. Got you back there. Who's our friend back there? Hi. Welcome. What do we... Ricky, you're blocking it. Yeah, there you go. Bennett, gotcha. I don't know. I'm seeing more red on this side of the room. That doesn't mean I put the right answer in. I'm notorious for not putting the right answer in. So, card 37. You're card 37. Okay. You ready? You're card 37. All right. The answer is trifluoroacetic acid. Okay. So the more electron withdrawing group, the more it stabilizes the conjugate base. Okay? And so then the more acidic it will be. Because you're taking those electrons on the oxygen of the conjugate base and they're able to be pulled through like the tide. Okay? More questions? All right, here we go. Another one. Which of the following is most acidic? Ethane, ethene, or ethine? You're blocking it back there. There we go. You actually, what's funny is if they're kind of like on one. Okay, I think this side of the room's got more right than the other side. Did he get it? Bennett?
Why do you want me? Why is it always me?
You're right there.
In the center.
Part 37. Okay. Fine. Okay. Remember the pKa's. The pKa's of those three hydrogens, the sp pKa was the highest because it has highest S character, which you will learn why later. We'll not go into that, okay? But higher S character leads to a lower pKa. All right? All right. There was one person, I don't know who it is. One person answered ethene. When you have three, always go for the extreme. You're taking the GRE, whatever it is. If you don't know, go for the extreme. The extreme's always the answer. And. I mean, you might have just turned your card wrong or whatever. But if you're taking a multiple choice and you're not really sure, always pick the longest answer.
That's what I usually do.
If you don't know, if you're guessing, I'm telling you.
This is how your quizzes work, right?
No, I try to go against that. But because I know. But I'm just telling you, out there in the world, when you take your Title IX training and you're like, oh, I don't remember which one that was, pick the longest answer.
Why do we
Okay?
do that?
That's actually true.
It's not my fault that you have to do that every year.
Darn people make stupid decisions.
No, you. Yeah, you know what? It's anyone that voted for President Obama. You can blame them.
Oh, God.
Wow.
That was his administration. Ethnic acid. Oh, it's ethanoic. I missed an O. Ethnic. That's a total. Right after I said Title IX training, it seemed like.
That's the answer?
That's an autocorrect. Autocorrect got me. Ethanoic acid is acetic. Ethanoic acid is acetic acid. Ethanoic acid, the same as acetic acid. Acetic is the old name.
Got swallowed up. You closed it in your book?
Choose one.
Just choose. I just pick that. Just put it up right.
So I always go with my gut. My gut always tells me
Then you're kind of sideways over there. Gotcha. All right. Amber? Gotcha. Wow, 85% of you got this right. Ethnic acid.
It does have good acid.
Okay.
Twice.
Anytime I put something up there that says acid, it should be the right answer, right? That should be the more acidic one.
What if there's multiple acids?
Now, I might remember, if I put like a mineral acid up there, like HCl or HBr, those are going to be more acidic than acetic acid.
It's also the longest answer.
That's also the longest answer. That's right. Okay. All right. How many questions did we do there?
Go till 2 o'clock.
Can we do this as the quiz?
Like, I love those ones. It's like, it's a competition, and I'm winning. Like, whenever I do the
Maybe it doesn't work. Okay. Here we go. Which of the following is the fastest in an SN1 mechanism?
It doesn't like me. Yes.
Hey, I didn't know that.
Autocorrect got me. It missed you? They got you. Got you twice. We got everybody? Okay. 29 of you got it right. Nobody said secondary. You listened. Tertiary. Okay. Allylic. I could have put allylic on there. That would have confused things because it's pretty close to tertiary and benzylic. But if I would have put allylic, it's faster than secondary for sure. If I would have had like a structure and one's tertiary and allylic, definitely faster. Okay, here we go. You guys should get this one. Little review here. The answer. Got a little Wi-Fi. You just experienced some slow electrons.
How important to you is this Wi-Fi, and how do you think we're doing that?
Okay. 2 people said secondary. On purpose. All right. There you go. This one's going to be primary. All right.
No. Not the kinetic alphabet. B is Bravo. Not beta. Bravo. Alpha.
Okay, here we go. Which of the following
SN1?
type of carbon undergoes SN reaction, substitution nucleophilic? SN. So it's generic either SN1 or SN2. There's a whole paragraph in the reading. You're blocking it. You got your finger over it a little bit.
There we go. Yeah, exactly.
Okay. Got everybody? SP3 only. Okay. The book talked about some reasons for that, but mainly speaking, these are poor carbocations. So, for example, when we did bromobenzene, okay, so this is not allylic or benzylic. This is an sp2 carbon. So allylic is different. Allylic is this, or benzylic. I'm sorry, this is benzylic. Okay, that's benzylic. That's different. That's very different. Super different. Like, oh, that one carbon makes a huge difference because I can draw all these resonance structures for this one. And I can put my positive charge all around that ring. Okay, just like exam 1 or quiz 1 or something. Okay, this I can't do that. So what stabilizes a carbocation? Resonance. But this one can't have resonance. What's the other one? Inductive effect? Inductive effect, the force. And there's really, because, so the p orbital, I'll explain this one time for the folks that, I'll give you just a little bit of pork here, okay? So that p orbital is in front and in back, okay? It is not lined up with the electrons of this carbon hydrogen or the electrons of that carbon hydrogen. They're in a different plane, so they can't contribute to any inductive effect. I mean, that's the real reason. So we only do substitution nucleophilic reactions on sp3 carbons. Yeah.
So when we have a carbocation like that, what orbital is the last electron going to be in? Is it going to be in any of them, or is it in the sp hybridized orbitals, or is it in the p orbitals?
That would have so it has 1, 2, 3. It would be in a p orbital.
Okay.
So it's so it has 2 p orbitals. So it'd be sp. That hybridization would be sp. Okay. All right. Just remember that. All right. Here we go. What is the best solvent for an SN1 reaction to occur?
Wait, no.
Protic solvents like methanol, polar aprotic solvents like acetone, nonpolar solvents like benzene. I taught a class of 75 one time. This would have been really fun. Could have taken roll.
Why does it not like it? There we go. Can I change my
It let you. Yeah, and you got it right. Okay, protic solvents. Okay, most of you got that one. So let's talk about that for just a second. So for an SN1 reaction to occur, just forgive me, and there's stuff out here, okay? Okay, so for an SN1 reaction to occur, these electrons have to leave, okay? So what happens is, so if I have a polar protic solvent, okay, which means that I have an available hydrogen, okay, it can begin hydrogen bonding with this as it comes off, and it like helps solvate it, okay, it helps it come off, and then when it's off, if I have PR minus, I have really great solvation. Oops, hydrogen. Okay, then I have really good. Okay, so that's why polar solvents. Let's just put this out there. This is why polar solvents are better for both SN1 and SN2. Okay. So all right. So I'm going to pause there because the next question is, here we go. And I'm going to move on to SN2. So why is the best solvent for SN2 reaction? What is the best solvent? Protic solvents, polar, aprotic solvents, nonpolar solvents. somehow making you vote. So, what I should put up here is like, what is the number one factor that's involved in Title IX complaints? Ethnic acid.
If you put it in there, only because we're going to know what that even means. You like somehow add a little question in there from ethnic acid.
Ethnic acid, yeah, I know. That's
Everyone's gonna be like,
okay. So before I reveal the answer here, what's the number one? It's part of it is an organic chemical. What's the number one factor in in the country? What's the number one factor in Title IX complaints? It is an organic molecule. What is it? Alcohol. Alcohol, number one. You got a lampshade on your head. Okay, so the answer here is polar aprotic solvent. So remember, this is solvation. I have to get this plus my carbocation. Okay, but over here, so that's in the rate determining step, right? We're going to make sure that's the rate. That's how a solvent affects the rate determining step. If I have my nucleophile plus my, let's say I have that. Okay, so we'll do methyl bromide. Polar solvents are better, but a protic solvent does the same thing. So it hydrogen bonds to my nucleophile. Okay? So you get this sphere of hydrogen bonded solvent around the nucleophile, which stabilizes the nucleophile and kind of softens it up. It's like you've put a big beach ball around around a marble, okay, and then you want the marble to like do something. Well, it's trapped inside this beach ball. So that's bad. So that's why you don't want a protic solvent. But an aprotic solvent, like acetone, won't hydrogen bond that same way. So it doesn't form the sphere of solvent around your nucleophile. And remember, in an SN2, you need both that and that for the reaction to occur. So that's why it slows down the reaction if you don't have that. All right. That's the extent of my quizzes. On the Plickers. All right. So, I tell you what. If I'll give you I'll answer any questions we've got, and I'll give you the quiz right now. And if you all promise. So I used to hand back a blank quiz, and then we'd go over it, and I thought that was really helpful. But I've got so many people out traveling that I figured a blank quiz, got a picture taken of it, and sent to people. Don't know if that were to happen or not. But I will not give you a quiz, but we'll go over it if you want to hang out after the quiz. Okay? So we'll have a few minutes at the end, maybe. Yes?
So I do have one more question. You're kind of going through the back of the book. There's one that kind of really confused me. It said that R2 bromooctane was stirred with sodium iodide and acetone at room temperature for 2 days. And then it said after experimentation showed the rate of the reaction was dependent on concentration of both the reactants and the nucleophile.
Okay.
The product was racemic in mixture, and it said rationalize this process.
Which one is it?
It's 17.
617?
617.
Okay, so bromo-octane. Okay, R2-bromo-octane. Okay, so rationalize it. Octane, 1, 2, 3, 4, 5, 6, 7, 1, 2, something like that. So that.
One last turn.
Okay.
That's not change anything.
Okay, so, all right. The problem, this is the reaction. Sodium iodide, did it give a solvent?
Acetate.
Acetate. Okay, so this is my chicken scratch there. Okay, so this is my explanation. They're just getting you to think about it. Okay? First thing that happens, and this is R or S, right? One of the two. So the first thing that happens is you get SN2 substitution. Okay? And if you stopped it after 1 hour, that's what you would have. But when you stir it for 2 days, it's like, I can think about a lot of different things. And so after a period of time, you gave it the opportunity to give that carbocation. And so then you've developed this equilibrium here with iodine and that carbocation.
And then after that, the iodine will come back.
Iodine's a better nucleophile. There's more iodine because you're reacting it in sodium iodide.
And the bromine should precipitate out, correct?
And the bromide would precipitate out in this situation, yeah.
So it's just the iodine just chilling out.
So it's because you
come back.
Right, because you set up this, which is not a great carbocation. In fact, a better question would be that you, because it's octane, whatever rearrangement, you're still going to get a secondary carbocation. But it's telling you that something SN2-ish happened here, and something SN1-ish happened here.
Okay. That makes sense.
Okay? You had Abby, did you have a question? No? Okay. All right. We'll pause you.